with dilations and ratios. We talked about this with regard to similar circles or dilations of circles. Okay, and dilations and similarity are going to fall hand in hand when we're talking about these ratios. Okay, and the ratios we're going to talk about with dilations or similar figures, okay, are the following. Okay, we discussed already that if the ratio of parts is given as m to n, then the ratio of areas for these same similar figures, so this is in similar figures. Remember, all circles were similar to each other, but these will be, as far as triangles are concerned, either dilations of a triangle form a similar one, or if you're specifically told you have similar triangles, then the ratio of areas is going to be that same ratio for every dimension being measured. So area measures 2 dimensions, and so our ratios will be m squared to n squared. And so what that would mean is if the ratio of parts is given as 2 over 3, then that means the ratio of their areas is going to be 2 squared to 3 squared. Okay, and these ratios will always involve or represent a conversion factor. So the conversion factor for areas is either going to be 4/9 or 9/4, all depending on whether you're looking to make something bigger, use 9/4, or smaller, 4/9. Okay. If I start by giving, or if it starts by giving you the ratio of their areas. So let's say you were given 81 to 64 as the ratio of areas, then you would work backwards. You could find the ratio of parts. What would the ratio of their individual parts be? 9 to 8. And once again, what that would represent is a conversion factor of 9 over 8 or 8 over 9, depending whether you're trying to move from something bigger to smaller or smaller to bigger. Okay, so I want you to see if you can answer these first 2 questions on the left. Okay, and then I'll talk through them, and then I'll have you try the problem on the right. But see if you can answer the 2 questions on the left. It's sort of the 2 applications of this relationship between ratio of parts and ratio of areas. So here, if you're told that 2 similar triangles have corresponding perimeters, which are one-dimensional measurements, so we're told that the parts have a ratio of 8 to 25. That means that their areas are going to be the squares of that, so 8 squared to 25 squared. So the conversion factor is either 64 over 625 or 625 over 64. And the way that you're going to apply this is you are going to take the given value, the 54.76, and you're going to multiply that by the desired ratio. So this is the area of the larger triangle. We want to find what the smaller one is. So which of these factors, conversion factors, will we use to move from bigger to smaller? The first one, right? So if we multiply this by 64 over 625, we'll get our solution. And so the answer, 54.76 times 64 over 625, will give you your solution of 5.61 approximately. Okay, the units are centimeters. We are finding an area, so it's square centimeters, and that would be our answer.